Hello everyone. This is homework number 4, the addition property of equality. First off, we need to understand the difference between an algebraic expression and a linear equation. And an algebraic expression does not contain an equal sign, so there's no equal sign in an algebraic expression. So here's an example. And the terms that contain the x or the m or the n or the p, these are the variable terms. So 5x and negative 8x would be the variable terms in this case. And when we just have numbers all by themselves, like the negative 7 and the negative 4 in this case, these are referred to as the constant terms. So you definitely want to be familiar with that terminology and being able to distinguish between the variable terms and the constant terms. And to simplify an algebraic expression, we use the phrase combine like terms. And the idea is that the variable terms are combined separately from the constant terms. So there's two ways that you could actually go about this. I'm going to show the two ways here. There's what's called the grouping method, where you could gather x together. So just move them around and gather the constants together. Now, by doing that, we actually used a couple properties of mathematics. When you group things, it's called the associative property. But we won't worry about the formality of that. And then you can combine the x's because they're now together. So 5x plus 8x, you just simply add the coefficients. So 5 and 8 is 13. And you keep that common variable factor. So 13x. And then you combine the constant terms. So a negative 3 and a positive 9 combine to give us a positive 6. And you have to write an addition or subtraction symbol between the variable term and the constant term. So since that was a positive 6, we write plus 6. And there's nothing to do further. You cannot combine variable terms and constant terms. So that's the grouping method. And then I'll just call this the underlining method, which is actually the method that I prefer. So I'll recopy the problem, and we'll just underline like terms. So 5x and 8x, just make sure you know that the coefficient, the sign in front of the coefficient, is the sign that belongs to that term. And it's understood if it's not written like the 5 here, that it's positive. You could slide a plus in there if you like. So I'm combining again a positive 5 and a positive 8 to get 13. And I keep that common variable term. And then maybe I'll underline the constant terms twice. And combining a negative 3 and a positive 9. Again, we get a positive 6, and we have to put the plus in there to keep the terms separated. So I think most people would either use the underlining method or maybe just do it mentally. But it's your choice, and I'm going to use the underlining method. So looking at this algebraic expression, I'm underlining the variable terms once, and combining 3 and negative 7, we get a negative 4, and you keep that common variable y, and then we'll combine the negative 5 and the negative 2, and we get a negative 7. So we write minus 7. And again, you cannot combine the variables with the constants. Okay, so the difference between an algebraic expression, and an algebraic equation, or what we often refer to as a linear equation, or just an equation, is that an equation contains an equal sign. And we can solve it for the variable. Now, here's a simple example. I said solve for x in this equation, x plus 4 equals 9. And so, intuitively, hopefully everybody would agree, we say x equals 5. And that would be because, or I'll just abbreviate cause, that's because if we plug a 5 in for x, we get 5 plus 4 is 9, and 9 equals 9, which is a true statement, and that checks. But then the question is, what about something more complicated? Like x minus 1789 equals 2020, or x plus 4/5 equals 5/6. Those aren't as easy to intuitively solve. And so the answer to that question is that we need an algebraic process. And one other thing to note, especially when you try your homework in my math lab, they'll mention equivalent equations. And basically the idea is if two equations are equivalent, they have the same solution. And so we get to a property that we use quite often, and it's not really, this is the property formally written, it's not really necessary to memorize the property the way it's written or anything like that. You can just simply use the property without recognizing the fact that you're using it. But it basically says that if you have two things that are equal, you can add another thing, the c, to both sides of the equation, or you could subtract that thing so to both sides of an equation, and you obtain equivalent equations. So basically, you can add or subtract any number to both sides of an equation. So in the x plus 4 equals 9, I'm going to recopy it just for the sake of showing the steps. And the idea is that we want to solve for x. We have to isolate the x. That's the whole idea, is to isolate the variable. We want to know what 1x is equal to. So x is whatever, some number. And so if we want to isolate the x, the 4 is on the same side as the equal sign. So we have to get rid of it. And what we do is we just simply add the opposite. To get rid of positive 4, we can subtract 4. Now watch the structure of the solution. If I'm subtracting 4 from this side, I'm going to line up the equals, and I'm going to subtract 4 from this side as well. I'm going to draw an addition bar. Now these 4's go away. I can bring down the x, but you don't have to write a plus 0 or anything. Just bring down the x and tuck it right in next to the equals. And notice how I'm lining up the equal signs there. And then just do the arithmetic. 9 minus 4 is 5. So that one was intuitively obvious, but here's an example that wasn't. Okay, I'm going to recopy again. And the idea is that I want to solve for x. I want to isolate this. I want to get all alone. I want x equals whatever. Well, I have to get rid of the negative 1789. And to do so, we add the opposite. So to zero it out, now we're going to add 1789. But whenever we do to one side of the equation, we have to do to the others. So notice how I'm the structure once again, line up the equals, and add 1789 to this side as well. Okay, now the 1789s go away. No need to write a +0 there. Once again, we bring down the x, and you could tuck it right in next to the equal sign. And then if you have to, use a calculator. This comes out to be 3809, so 3,809. Okay, so you need to be versatile no matter what side of the equation the variable is on. Most people, most students I know from experience are comfortable with the variable on the left-hand side. But if it's on the right-hand side, deal with it. Just leave it there and use the concept of trying to isolate it. So again, if I recopy, I'm just recopying, so it makes for a nicer solution rather than trying to squeeze it in there. But of course, you could do whatever you want. But now I want to get the p all by itself. So it's on the right-hand side. I'm just going to leave it there. And I need to get rid of this 5. It's positive. So to undo it, that's basically what we're doing here. We're just undoing things. We can subtract 5. I'll line up the equal sign, and if I subtract 5 from that side, I subtract 5 from this side as well. And now I combine a -9 and a -5. Same sign, add the numbers, keep the sign. I'm assuming you're comfortable with sign number arithmetic. If not, we'll review that in class. And then the 5s go away, and then we just bring down the p. So that's the same as saying that p equals -14. Okay, we talked about that before when we solved proportions. You don't have to rewrite it. You can just leave it that -14 equals p. And just read it from the right. P equals -14. Okay, so here's another example that I'll recopy. Decimals can be involved. And so I want to isolate the y. I need to get rid of the -1.9. So I'm going to add the opposite, or add 1.9 to zero it out. So therefore I have to add 1.9 to the right side as well. Draw my addition bar. 1.9's go away, bring down the y, line up the equals. If you need a calculator for that, you should feel embarrassed. But feel free to use it. And that's 5.3. Okay, and then fractions. So you just have to deal with fractions, but remember we do have the fraction calculator, and I'll show you once again how to use that. But the idea, isolating the x, I want to get rid of the positive 4/5. So I'm going to subtract 4/5 from both sides. 4/5 go away, I bring down the x, tuck it in next to the equals, and maybe we need to do some side work. So if you have to add or combine 5/6 minus 4/5, we're going to need a least common denominator. In this case, that's 6 times 5, or 30. So we're going to build up each fraction to have that denominator of 30 by multiplying in the first one. 6 times 5 will give us 30, so we'll multiply numerator and denominator by 5 to give us 25 over 30. And we have to get the denominator of 30 here, so 5 times what is 30? That would be 6. And so the numerator is multiplied by 6 as well. So we get minus 24 over 30. And now we can combine them because they have the least common denominator. So we keep the denominator of 30. And 25 minus 24 is just 1. So 1 over 30. Okay, so you should just deal with the fractions. But if you want, Look at how nicely the calculator works. We've talked about the A with the B over C key before. That is right above the SIN button. That's actually sign. Is the A with the B over C. That's our fraction key, right? Here you can see it better if I point with the red. So that's the A with the B over C. And all you have to do is type in 5, hit that key, 6, that's 5, 6. Remember the fraction calculator uses that little backwards L to indicate a fraction bar. And then we're just simply subtracting 4/5, so 4, fraction key, 5, and press equals. And it does all that work for us and gives us the answer of 1/30. So again, if you haven't purchased this calculator, I would strongly encourage you to do so. Alright, now here's a fancy word. You could use this to impress your friends at parties. When you move things from one side of an equation to another, it's called a transposition. So get used to hearing me say transpose, okay? And all that it means is that you're moving a term from one side of an equation to the other. And if we have a situation where the variable is on both sides of the equation, we have to choose a side to bring the variable to. And we generally use the idea that it is best to bring the variable to the side where the coefficient is greater. So when I look at question 6, the first thing I see is, oops, variables on both sides. Now let me recopy it because again I just want to be able to show the work neatly. So I see the variables on both sides. So then I just ask the question, which side has the larger coefficient or the greater coefficient? And obviously 8 is greater than 7. So therefore we're going to transpose this 7y first. You always want to move the variable first, because once you get the variable on one side isolated, then it's just a matter of doing what we did in the previous examples. So therefore, if I want to move the 7y to the left-hand side, I'm going to subtract 7y. I'm going to line up the equals and subtract 7y. And notice how I put it underneath the like term, underneath the y. And then when subtracting, 8 minus 7 is 1. That's 1y, or just simply y. Now I have to bring down the 3, line up the equals. I don't have to write a 0 or anything there. Those 7y's are gone. They cancel each other out. And that gives -5. Now there was really no need to write the 1 there. Okay, if you wanted to, just simply y. We know when if it's not written, that it's understood. Okay, the coefficient, that is, if it's not written, it's understood to be a 1. Okay, and now notice that I have a situation like the previous examples, where all I need to do, I've got the variable on one side, I need the numbers on the other side. So I have to undo the positive 3 by subtracting 3. So subtract 3 from both sides, line up the equals. Okay, the 3's are gone. I'll bring down the y. I'll tuck it right in next to the equal sign. And now combine a -5 and a -3 to get a -8. Okay, but notice in number 7, again the variable is on both sides, but the coefficient is greater on the right. So therefore I want to move or transpose the 2q to the right hand side. And again I'm going to recopy the equation. 2q plus 5 equals 3q minus 2. And if I'm going to move the 2q to the right, I'm going to subtract 2q from both sides. So I'll line up the equals, and I'll subtract the 2q. I'm going to put it right under the 3q, because those are like terms. And now my addition bar stretching across the entire equation. The two q's go away. We can bring down the 5. 3q minus 2q is 1q, or just simply q. Then bring down the negative 2. And once again, we have a situation like the previous set of problems where we've isolated the variable. It is on one side, and so therefore we're going to need to get rid of the negative 2 in this case, so add the opposite or add 2. And if we add 2 to that side, line up the equals, add 2 to this side as well, draw the addition bar, 5 plus 2 is 7, that equals q, and there's no need to write a plus 0. Okay, I'm going to stop right there, and then we'll come back and we'll finish up this lesson, this homework for number 4 in the second part.